And for this panel, I'd like to bring on Ed from Offchain Labs and Illia from Near. I'm going to talk about how AI and blockchain intersect. So without further ado, let's welcome them both on stage.
Hello. Thank you, Kartik.
Hey.
Ed. So we've done a lot of conversations together, and one kind of cool thing here is that we always end up learning super interesting things that are just on top of your minds. And this one is a very interesting one because both of you have had experience and direct work in these kind of fields, and now we get to intersect AI and blockchain. So my kind of first question to you both is kind of looking at your past background from kind of Google Research in Princeton, and then kind of transition into focusing a lot of your time on blockchain scalability. I'm kind of curious to understand how has research influenced how you see practical applications being built and kind of bringing those research ideas into the real world, and where do you kind of see the world of AI shaping in for your personal interests? And maybe it'll be good to start with that.
Sure. Yeah, the way I think about research is, and impact as a researcher, was always to try to look for what are kind of the fundamental hard problems, what are the barriers or roadblocks that are stopping the progress that everyone sees is possible, and then figure out what are those barriers and then how to knock them down. So, you're really focused on fundamentals. And so, I got into this field through looking at fundamental issues around, I got into blockchain by looking at fundamental issues around how to scale. But one of the things I think a research background is useful for is that it helps you spot the big picture and to sort of find the leverage points. What are the technical leverage points you need to attack? And then look at the big picture. I mean, for me, the exciting thing about both blockchain and AI is that they have the potential to change the relationship that people have with technology, right? With blockchain, it's about, by putting things on chain, they become more transparent, more accountable. They can be governed more by community instead of, behind the walls of some data center. And AI is the same kind of thing. It's a way of empowering people, especially people who have less facility with programming, to actually be empowered and to be able to do more with technology than they thought they could before. So for me, it's really exciting to be able to look and say, what are the hard, interesting technical problems at the core of making this vision happen? And then just to go after those.
Yeah, so for me, actually, we got into blockchain because we were doing AI startup in 2018. And we were doing a lot of data labeling at the time to effectively train our model. And the challenge was paying people, like coordinating people effectively with incentives. We had people around the world. Some of them didn't have banks. A lot of countries they were in had some restrictions on transferring money. And so we started looking at blockchain just to solve our own problem, and kind of obviously second Ed's position that, when you start looking at some problems, you start looking at okay, why is this the state? Like, what is the fundamental blockers, right? And that's kind of how we got to build Near. But I agree that kind of what influence for me is how do we use these tools to coordinate? Because one of the challenges, I think, in general, kind of research has a lot of broken components, right? The grant systems, the corporate research, there's all of these incentives that are quite misaligned, and they don't have the same kind of outcome. Like, how do we advance the world because of all of this kind of misaligned incentives? And I think kind of blockchain crypto industry offers, obviously it has its own misaligned incentives, but offers a way to structure incentives in a constructive way where you can actually advance technology, bring something to the world, and reward everybody who participated in this. And I think, again, that's kind of what attracted us back in the day to do data labeling and kind of these things. And I think this is where very attractive right now for AI, where we see big labs are closing up, right? Not open sourcing. not allowing other people to participate. In fact, the open source now is used as like a weapon, kind of, than actually to advance the science. And so, yeah, I think of blockchain always as like, hey, how do we coordinate people in more effective ways? How do we incentivize people to really create common goods, even if people's individual incentives are, self-interested, right? I mean, that's kind of the story of Bitcoin, right? Everybody's self-interested, but the result is, public good that everybody can use.
Both of you kind of ended up bringing in something pretty interesting, and we have a few more questions we want to cover on that topic, but it might just be easy to surface this now, which is the difference in definition of what the AI community thinks open source and like non-centralization means, which may not be the same as decentralization, is kind of a very different interpretation that the crypto community does. So what I'm curious about is knowing kind of how do you each define what does it mean to kind of see crypto and AI look like as an overlap, and I guess from your past experiences and even just kind of now your refreshed view of this world, how do you kind of feel the AI community right now interprets decentralization and the crypto community in terms of actually bringing both of these things together?
You want to go first?
Sure. Yeah. I don't think AI community uses the word decentralization that much. I think there's a set of values that are there in open source AI community, which are obviously like, permissionless access, ability to, keep your data private, ability to kind of build on top of it easily. And those are very much the same as what we have in crypto. And I think one kind of specific property that, like, we summarize all of this decentralization, and I really kind of, like, I've talked about this before, that decentralization is not the point. It's actually a way we get the properties we want, right? And so if you can get them some other way, that's great. But one of the properties in decentralization that I think AI is very much missing is effectively, some property of liveness, right? Some guarantee that this thing will actually be there. And so right now that, especially on the, like, from evolutionary perspective, doesn't exist, right? Like, yes, Meta maybe published a model, but we have no idea if they're going to publish the next one, right? So like, you have no guarantees that there's going to be continuity of some service or property, even if it has other properties, out there. And I think that's where, again, crypto and blockchain has kind of a opportunity to come in and provide that, right? Hey, we have the incentives and kind of coordination to make sure there's continuity of this thing, and then we align on permissionlessness and kind of ability to build on top of it, etc. So that's kind of how I see this, both convergence and kind of where some of the divergence right now is.
Maybe as a quick clarification, what does it mean to have liveness for AI? Are we purely talking about availability of kind of the expectation that I'm going to get a response and not having a central point of failure, or something else?
So I think that is important. So I think of this as more like a general value, right? Like, when you have like a general liveness of things, right, you can build on top of it permissionlessly really easily, and you don't need to worry that you're going to get rug pulled effectively.
So that's kind of what we have. This, and it's accessible at all times.
Yeah. So services, libraries, new foundational models, like that's like, I talk about it in a more broader sense. I mean, definitely for any like inference service, etc. Right now, all of them are still, like, you don't have any guarantees. We actually have something coming out. We have a paper coming out on this exact thing soon. But even beyond that, yeah, like, how do you guarantee that the next model, foundational model, the next advancement will come and not get kind of consumed? So like those kind of things are not there.
Yeah. So for me, in terms of decentralization, I think it's really about who has power or who has control, right? It's really about, so one thing about blockchains are that they are shared resources. The whole point is that everyone can come there, even though we may have misaligned interests, we may have different goals, and that it is a shared environment with sort of a single rule set about how things interact with each other, right? And so then the key question is, okay, how does that get decided? What are the rules? How do the rules change? How does this evolve over time? Who's got the power in order to do that, right? And really effective, successful blockchains do an amazing job of creating something that seems almost magical, right? That you have this space where parties can interact in a fair and transparent way, even though they have very different goals, and things work out, and decisions get made collectively about how all that is going to be managed at the technical level. It's an incredible thing, right? And it's something. It's both a big challenge for the blockchain space that we have to do this, but also it's the main reason why the things that we're doing have value, right? And so that's the thing that blockchain can provide to the AI world, is when you move AI things on chain or chain adjacent, you do change kind of the rules of engagement, and that can be really powerful, right? Because in the AI world, people talk about, there's a lot of talk about power and a lot of talk about who has access to what and so on, a lot of push and pull between different players. But there's not really a central space where they all have to work together like we have with blockchain. But blockchain can provide that.
I think one piece that I feel like I have noticed, especially over the last few weeks, when we kind of looked at everybody's application was trying to hack, is they kind of compartmentalize where crypto fits in to AI. For them, it's kind of like the equivalent of, I really want to do something with AI, but I should see if I can swap one or two things and use blockchains for it. And that's kind of what my mashup is. And obviously, there's nothing wrong with that, because it's how we started in our own ecosystem too. You kind of look at how do you sort of swap and make a better platform over time. But the thing I'm kind of curious about is, from what you've seen and the interesting pieces, you both represent two interesting ecosystems here that are all kind of still working together. So maybe starting with that again, like how do you kind of see rollups in general and kind of the EVM giving people leverage for how they can understand where crypto and AI fits in, and just overall, how that better?
Yeah. I mean, it starts partly with the community and what people are doing, how they work together, and so on. Our team, working in the Arbitrum community, we've been really focusing on trying to sort of upgrade the capabilities of a chain. Starting with EVM, we shipped Arbitrum Stylus, which allows people to write smart contracts in other languages, Rust, C++, and run them composably on the same chain with EVM. Right. So, I think letting people program in familiar ways and getting the speed advantage that you get from being able to go at the speed of native code rather than the speed of EVM, of an EVM interpreter, that makes a big difference. And so, there's been a focus on trying to sort of upgrade the developer experience, if you will, without taking away everything that people know and love about EVM. It's all there. You can call it, you can use it, you can compose with it, but also you can program in a more familiar way. So I think that's one piece of it, for sure. On the technical side, the other one has to do with data. Right? AI applications can be data hungry. If you're going to be doing stuff on chain, especially, you need to have a really strong story about how applications can store, access, use data that is accessible on chain. And that also requires a lot of careful thinking, because I think one of the great strengths of EVM and Ethereum is the really careful thinking about gas and cost accounting, and the ability to have a system that very robustly allows home users to run nodes, and yet still provides a very general programming platform. So, I sort of think of, within that tradition and within that approach of kind of sustainability and the ability of home users to run nodes, how do we get rid of the parts of or improve the parts of the EVM experience that people do complain about, and so you can have the best of both. That's really what we've been focusing on doing.
I'm going to get into like what you've seen so far as well, but it's interesting because Illia, you kind of have a similar view, and you've kind of taken the WASM approach. How do you kind of think about making that experience better as you now see a big increase in AI applications?
Yeah, so I mean, we've taken a kind of approach to use WASM from day one because we believed that we want to give developers the flexibility to build with whatever language, but also because we wanted them to be able to use any library, right? One of the challenges with EVM always been like you're kind of relying on whatever 2,000 crypto developers to kind of build everything.
Yep.
And I mean, Near actually is a home for probably the most complex smart contracts in Web3, right? We actually have EVM, full EVM implementation running as smart contract, right? I don't think any other chain is even possibly can like fit that into limits. But the other thing we've done is that our VM is asynchronous. And so when you're interacting with contracts, you are effectively sending asynchronous messages. And every account and contract is effectively, you can consider them different rollup or chain or whatever. And we just like package and make it really nice experience. That's why we're also doing a lot of chain abstraction, because it's very natural for us because we already abstracted effectively all the near chains under the hood. But the interesting thing for AI is, and broadly for verifiable compute, is that we can now directly in the same transaction yield the transaction execution and call a method inside a secure enclave, which can run AI inference, which can run some complex computing, which can do pull information from internet and APIs, make a decision, and push it back on chain and restore the execution of the same transaction. Right. So to give you an example, you can effectively call an AMM contract. This AMM, instead of deciding that X, Y equal K, it actually runs an AI model that does inference over whatever the market state is, and decides, that you should get this much tokens, and sends that reply back on chain, and you receive those tokens in one transaction from a user perspective. So that's kind of like you can effectively overlay AI execution and calling other services directly into execution of your smart contracts, and you get very similar properties from executing inside secure enclaves because they effectively give you verifiability and privacy and other properties from there. Now, I mean, obviously there's asterisks there, but that's kind of how we think about it, is like really expanding capabilities of what you can do on chain with this kind of TV compute.
How might be helpful for especially the developers here who are listening. How does what's a good way to think about intuition around doing something like that in this example, and then understanding there's also a notion of a block time where I gotta make sure everything fits in that same limit, and what's like a way we can simplify on how to think about these things, because some of these are not going to be 100 millisecond actions.
Yeah, so that's one point. Like on Near, it doesn't matter. Like it can take 5 seconds and then you can resume the transaction. So Near transactions can take multiple block times, and effectively every cross-contract call on Near is a message passing to another entity, right? Be that another contract, or in this case, we added ability to send it to a verifiable compute engine. And so or you can send it to Ethereum, or you can send it to Solana, right? So to Bitcoin even. So like Near itself, you can think of it as like a multi-chain, multi-execution environment that kind of orchestrating message passing around the whole Web3. And that includes all the AI inference capabilities and everything else. I also add, because of WASM, we've had kind of JavaScript and TypeScript for a long time, but we're just adding Python as well. And so you can write smart contracts in Python now. And so now you effectively can write Python smart contract that calls into Python agent code that runs, PyTorch model and gives you back result. And you can interpret it in your Python code to act something on chain, or send a transaction or send a message call to another chain. So through Near, you can effectively have AI inference actually posting stuff on Solana or Ton or Ethereum or Arbitrum or even Bitcoin.
And is it a similar way to think about this for Stylus as well, Ed?
Sure. Yeah. I mean, the whole point is to sort of unlock the ability of programmers to express what they want to express, right? And then you get to the scaling problem, right? Which is, there's an unlimited number of programmers who want to do stuff that is as complicated as the chain and sophisticated as the chain will let them do. But there are resource limits, right? The nodes of your chain, the proving system of your chain needs to be able to handle the resources you have, right? And because demand is so high, resources will always, there is always a need to manage resources. Resources will always kind of be scarce, right? The point of a blockchain is that different people's applications, different smart contracts, and so on can interact with each other, right? It's that kind of that sort of a gathering place, if you will, where they can talk to each other. And so, we're really focused on trying to drive the efficiency of that execution as far as we can, and then present to users the tools they need to manage complexity and resources and so on. Because ultimately, just like when you're doing cutting edge programming, that you're going to be using you'd like to use a lot of resources. And so you're concerned about cost and scaling considerations. Everybody has to be, programmers have to be. And the way we think about this is, first of all, to provide as much resource as we can. And then second, to give people the tools and the feedback that they need in order to manage the resources they're using in their application as effectively as they can.
A good piece of what I want to use this panel for is actually helping either understand things a bit better in terms of how developers should make the best use of leveraging blockchains and kind of what we can help them unlearn. So kind of the two follow-up questions I have from both of your replies are, one, does this significantly change the definition of what it means to have on-chain inference now? Because we've kind of, at least my interpretation for both these answers is that we've now abstracted things to be just message passing. And what matters now is as long as we can communicate things, whether it's over blocks or just to the end place, whether it's on-chain or off-chain, we've effectively just used a blockchain as the orchestration for orchestration. But when you have things like, okay, I want to have a complex prompt and I'm going to have it do reasoning, and even if I pass it on to an open source model here like Llama, and it takes 20 seconds to get a reply back, or maybe up to a minute, what's a good way to think about, okay, how should that be built as an on-chain interaction? Is it just I just wait it out and have somebody just deal with the data and then send it back to me, and all I care about is the integrity of the encrypted message? Or should I be introduced to a new concept? How can we simplify LLM specifically here, and do both of your ecosystems have a different interpretation for this?
Yeah, I don't know about whether there's different solutions. I think, time and asynchrony are actually really important to think about. Understanding what it is that you need, what assumptions you need to make. In a lot of the applications that people are focused on, I'm thinking of things like DeFi and gaming, timing is really important, right? Not only how long does it take you to actually take an action when the world changes, because fundamentally the world that you or your application are in is always changing, and you need to be able to decide and act before the world changes again. And so that becomes important, just thinking about this timing. The other thing that you see is in some applications is what's sometimes called MEV, which is basically about somebody seeing what you're trying to do and then sort of jumping in front of you, right? So if somebody sees you sent a query off to a model, that may be a hint for them to, if you're in a market or you're in a game or you're in some situation where you're interacting strategically with them, you need to think about what it is that they're seeing you doing, and how they might react to that. So one of the reasons why original blockchain models were focused so much on synchronous execution, synchronous transactions, is they make it a lot easier to reason about that stuff. But I think, one of the pieces of advice is just to think really carefully about timing, think really carefully about latency, think really carefully about, if you're in a strategic environment, what it is that will be visible to the strategic rivals of you or your user in terms of what it is that you're doing. And that can be fine, right? Depending on which application you're in, but I think it requires application specific thinking. And these are going to be some of the hardest issues, right? There's work going on, I think, in a lot of different communities to try to develop programming models, programming tools that are going to help people cope with all of this so that balls don't get dropped. In the same way that in programming of internet services, there's a set of tools that arose for writing asynchronous programs that interacted with other, say, APIs across the net, and the different ways of managing that and dealing with errors and so on. And I think the same kind of facilities are going to fall out here, especially when you get into more complex and cross-chain worlds, because there are complexities that come up with asynchrony. There are errors or other things that can happen, and getting to a point where programmers don't have to think as much about that stuff is, I think, a big picture goal that all of us are going to be working on for some time.
Illia, you are muted. I'll get you.
Yeah, from our side, I think first it's important, to define something. So we define effectively an assistant agent, right? So this is something that runs on the user side, and it's effectively designed to benefit you and kind of be on your side, right? So think of it as your co-pilot or your interface to the internet. And I mean, a longer term, I think the assistant agents is actually how we're gonna use all of the computing and internet and communicate to each other, and all the apps are going to disappear and websites are going to disappear. So that is like one.
Just casually assuming that is that right?
We can go down that line. I mean, that's effectively just I think it's self-evident at this point. So
forget the internet. We'll.
Well, and I mean, the interesting thing is actually it's going to drive everything to be more peer-to-peer, because right now you effectively have checkpoints to go through, like Google and other aggregators. And if your AI assistant can inspect the whole world, at any time and evaluate it, you don't need to go to checkpoints. But anyway, putting that aside, so you have AI assistant. That's effectively, from a crypto perspective, just to give you use cases, this can be anything from like, hey, go DCA into this thing. Make sure my portfolio is, not get liquidated, etc. Right? Like you could give it instructions to do things, it executes it on your behalf. Now, the second type we define is effectively, we call them verifiable agents, where you have an agent that is running inside secure enclave. You know that, this code and this kind of model is running, so you know what to expect. It may still be non-deterministic because it's fetching external data, right? So like the exact state of the world is changing. So this verifiable agents can, either be pieces of functionality, or they can be like orchestrators. So, hey, run a marketing campaign. It's like, cool, I'll do it. Let me find other agents and people to do it and coordinate them. And so they can themselves actually act on chain, right? They're like, oh, okay, I'm a verifiable agent that knows how to rebalance portfolios, et cetera, in the backend. Finally, we call them on-chain agents, although we're actually exploring the name called based agents. And so this is where the smart contract itself has the logic and execution, and it uses effectively external compute, right, inside secure enclave as a kind of, offload to it. And so the difference here between verifiable agent is like verifiable agent, it has its own key, it manages all that, and it's effectively like constrained by security of that TE. And on-chain agent uses TE, but like kind of doesn't fully trust it, right? It can verify whatever conditions and can apply any restrictions on top of it. It can, ensure liveness, etc. Through that. And again, we have some work coming on how to ensure liveness and response across a decentralized cloud. And so those are effectively like, I think when people say on-chain agents, like people imagine those things where you're effectively writing some smart contract code that can call things, but actually nobody built those like so far, because it's actually very hard. And so we have the whole framework to do this. You can do this. We have like Oracle example. We have this AMM example I mentioned, and Near is very well designed for that because of this asynchronicity at the core. So you literally are in the same transaction, right? So you have all the same context when the response comes back, which normally you wouldn't have. But verifiable agent, I think, is like extremely important concept that because they also serve as private, right? Any session that users have is private. you now can actually have them do, read your email and act upon that. You can have them, act with the credentials of their website to optimize SEO and all these other use cases in real world that, people right now are actually paying money for somebody else to do.
I think both of you have mentioned a pretty consistent theme around sort of leveraging secure enclaves and TEEs for a lot of this, and it kind of is very obvious because it fits in nicely with how we interact with these services. But mostly curious to see, are there any obvious things that zero-knowledge proofs can simplify or enable when we kind of leverage these things? And I'm curious what that looks like.
Sure. Yeah. One of the places where zero-knowledge proofs, in principle, can help is if you have a situation where there is a model that is agreed upon, or someone is committed to the model, and they want to prove that applying the model to some data yields some particular result, right? And there's different ways of doing that, right? So in the in the blockchain space, when people talk about zero knowledge, right? If you were to talk to a cryptographer, for them, zero knowledge means something about privacy or confidentiality, right? And there are applications where that's what you want, right? Where maybe, I say, I have a rule for making decisions about people or situations, and I'm cryptographically committing to the rule, but I'm not telling you what it is. And then later I can prove that I applied my committed rule to the particular data you gave. Right. So like I have a model that can predict who's going to win who's going to win the next Champions League game or something. And I'm not telling you, based on whatever data about the players or the teams, I'm not telling you what my model is, but I'm committing to it now. And then like later I can prove to you that, applied to this data, here's the result. So that is using the zero knowledge aspect of zero knowledge proofs. Right. But you can also do the other thing that people in blockchain do, which is to quote unquote ZK, which is that you're using these sort of concise cryptographic proofs, but not for secrecy, but just like for some notion of efficiency. And there again, maybe you have a model that is too expensive to evaluate on chain, but you can publish some cryptographic commitment to the model, and now somebody can prove to an on-chain contract that yes, this is the result of executing that complicated model on particular data. And that also is very empowering because it lets you move sort of off chain into a kind of coprocessor, the evaluation of the model. But in order to do that, you need to be able to generate efficiently that concise, easily checkable proof of model evaluation. And that's a real technical challenge to be able to do that on models that are large and sort of cutting edge. A lot of interesting research.
Not deterministic, right? Sorry? And also non-deterministic. So,
well, it had better be deterministic if you're going to prove it, right?
Yeah, exactly. It's hard to back apply it, not without.
Right. But you can take these models and make them deterministic in a sense, where there is a deterministic answer, right? And then, there's different ways to work around that, but fundamentally, one of the annoying problems you need to deal with if you're working on this model proving stuff is how to deal with the fact that typical model evaluations are mildly non-deterministic, right? There's a whole set of technical challenges there, right? But people are going to be pushing that envelope, and I think we're going to see more and more sophisticated model evaluations being provable on chain.
Sorry. I mean, to be clear, the reason why they're non-deterministic is hardware. Like the model itself, computation is deterministic. I mean, given a seed, like for sampling.
Yeah.
The reason why they're non-deterministic is because NVIDIA GPUs are effectively optimizing in parallel when they do matrix multiplication, and rounding errors accumulate.
Exactly right. Yes, that's right. Floating point arithmetic is not actually commutative and associative.
Yeah. So I mean, I agree that this is like a very nice use case, but indeed it's like very non-practical right now, right? This is not really applicable right now. Like any model that anybody wants to use is effectively not ZK provable in like reasonable amount of time, meaning like I'm not even talking minutes, it's probably hours. And And I mean, obviously, we all hear for ZK continues to speed up, and like there's a ton of research put into implementing this. But indeed, like from my perspective, TEs right now solve all of these problems, and they solve privacy as well. So like to me, TEs right now are effectively solving privacy and verifiability. And yes, they have kind of there is ways to attack them in from a few different directions. But given we are piping data, like large amounts of data through them instead of what normally people use them for, like private key material and stuff, it's like so much harder to get anything out in those cases because all the attacks are like side channeling. And the 2 nanometer Intel CPUs now, like from an even hardware perspective, trying to like effectively uncover the hardware private key on the chip. I mean, at least like an analysis of security researchers is that it's kind of highly technically like the cost of that is extremely high, right? So again, wouldn't store like on a single T, all everybody's money. Like that's not, but like for any kind of data piping, inference AI, I think it's actually a very good solution. And then, yeah, I mean, we should continue investing in speeding up ZK for sure. And then we can actually have both.
No, that's it's obviously it's a moving target too, and we kind of get to understand what the limits are and improve them, and that's quite kind of frankly what the goal of research is, and you kind of define the new constraints and see if you can exceed or reach. 2 more questions before we end this. A quick one will be, I guess, from what you've seen in your ecosystems or just generally in the space, what are kind of cool and interesting crypto AI mashups and applications that you've been excited about? And
I mean, I think the first things we saw for sure were people just putting agents in, especially in DeFi, to act on their behalf. Nothing too sophisticated, is just really the ability to have an agent and to have it engage in some kind of more sophisticated behavior than just like a simple if-then rule set. There's a lot of low-hanging fruit you can get without going to the most advanced AI as AI. And I think that's really what we've seen more of than anything else. There are people pushing the boundaries, trying to understand what are the limits. But, as in any kind of engineering, making very practical decisions and not getting too fancy or complicated for the problem you need to solve. I think I've been impressed by just sort of how practical people have been in thinking about what to do.
That's awesome. Illia?
So yeah, I mean, from our side, like last year, we invested a lot in kind of building out like fundamental infrastructure. So this is, kind of tokenization of compute to make sure that, there's a kind of ability, like liquidity in compute markets. Some of the kind of inference, distributed decentralized inference, some of the foundational models that are trained specialized for example, on-chain data, so you are able to have like a lot richer information, agentic payments, and kind of synthetic data crowdsourcing. So kind of the more fundamental blocks. The way we saw this is, if we want to have a alternative to one of those closed labs, we kind of need to have that stack available, and people can address this. In parallel, obviously, as Ed said, there's kind of a bunch of people attacking this from like, okay, well, how do I give people tools to use the blockchain in a more natural way? Again, in this mindset of like chain abstraction, like the final form of chain abstraction is just talking to AI, right? You don't really need to think that there is blockchain even existing. So Bit is a really good example of like a fully chain abstracted wallet. It can use thousands of chains. It's all AI. There's a ton of agents that can actually like plug in and execute actions for you. So that's kind of one direction. I think what we see kind of as the next wave now coming is actually starting to replace different functions, where right now you either have people or some kind of very strict game design, like game theory design, which is not very sophisticated, right? So the examples are obviously the governance, right? So starting with like your governance copilot, right? Something that can summarize all your governance forum threads and give you like actually what you should know about this topic, but also going into what does AI delegate looks like? What is like replacing the person, like especially right now, there's like professional delegate companies, which are effectively just like doing that as a company. Like, what does that replacement looks like? It can summarize all this information. It can make decisions. It can propose things. It can query its, its delegates. And then the thing that I'm really excited, I mean, this is more long term, is AI president. So like actually managing work, right, in a DAO or in a company, full end to end, right, removing hierarchy. The other examples are, AI like oracles. Right now, there's humans effectively resolving, like for prediction markets or for like more complex questions. There's humans resolving effectively markets based on reading information on the website and deciding if something happened, like did Trump win or not, did this team win or not. Like that is replaceable by AI now. Obviously, there is still gaps in its understanding, so you need a backdrop with people, but you can start automating 80-90% of the work. So effectively now it's moving into this direction where like you find places where right now you need a human in the loop and reduce that time and requirement 80-90%, and you still have a human behind to kind of make sure it's going. And so I think that's gonna be like the theme for this year. And that's, as I was saying, kind of some of the mechanisms we've built is exactly for that.
Oh, that's awesome. And this is probably a really good note to end on, because this kind of gives us a good look into what, I guess, from your prediction, just this year looks like. So I can't wait to see for the next year AI hackathon, just one of the AI bots being the other panelist. We'll see how that goes. But
you don't know if I'm AI or not, though.
Well, I do know, because you were muted for a while. You were talking, so anyone can make that mistake. Unless you program that, of course.
Yeah, no, obviously, right. That should be built in. We can go all the way back to Turing's original paper on the Turing test, and in it,
you need to trick them. Yeah.
But Ed, Illia, thank you so much for this chat, and we'll keep you posted on the cool projects to come out of this next week. Really appreciate your time.
All right. Thank you, Kartik.
Yep.
Take care.